this is sort of our last elimination method of solving systems. So elimination method is a method for solving a system that involves, all this involves is adding or subtracting equations to eliminate a variable. So I want you to think elementary. When you first learned how to add and subtract in elementary school, you learned to do it vertically. So if I had 27 minus 15, you did your ones place and then you did your tens place. So that's what I want you to keep in mind today. So step 1 is to add or subtract the equations to eliminate one variable. And then we're going to solve for the remaining equation for the variable that remains. Now I know that you're like, what? This is just a bunch of words. Just trust me. I will show you the steps with the math in a moment. We are going to substitute. This third step is the same as what we did on substitution method. We're going to get our solution for a variable. We're going to plug it into either equation, original equation. You don't want to use one that you've changed. So always use that original equation and solve for the remaining variable. Now, you're like, what? So I'm going to let you get caught up. So let's look at this in action. So again, we are thinking elementary. So we are looking at this in columns. Here's my equals bar. Technically, we're adding these. We'll see. So we can look right here. Vertically, 2x minus 2x, those eliminate. Thus the name elimination method. 3y plus 5y is 8y. 11 plus 13 is 24. Now that looks nice and pretty. We're used to solving that. We would divide by 8. And y equals 3. Very nice. So that is only the first part of our coordinate. Remember, a solution to a system is, in fact, a coordinate x and y. So look, we've already done, this was step 1. This is step 2. Step 3, we got to plug this into one of these original. It doesn't matter which one. Which one do you want to do? The top one. All right, so step 3 says 2x. Make sure you plug it in for the correct variable. Some of you solved and didn't plug it in for the correct variable. So we have 2x plus 9 equals 11. 2x equals 2. X equals 1. So my solution, my coordinate point for this system is 1, 3. Okay, that means if I put 1 in place of x on both of my equations and 3 in place of y on both of my equations, I will get a true statement. All right? So you can manipulate your equations, and as long as they line up nicely, so if this was like 2x equals negative 3y plus 11 and negative 2x equals negative 5y plus 13, as long as your matching variables are in the appropriate columns and you've got the same thing on your equals, you're fine. Most of the time we see this in standard form though. All right? Good question. So, but you can technically do this in any form. So let's look at example 2. What do you notice about example 2? The y coefficients are the same, but they're not going to eliminate. One needs to be what? Negative. So how do we make something negative? What? Okay, both of them multiplied by negative 1. Just one, and it doesn't matter. Choose. I'm going to choose the top one. So I now have negative 4x minus 3y equals a negative 2. I'm going to go ahead and rewrite this one because then I'm not looking at things diagonal and confusing myself. And now I can look at my columns. My y's cancel. Negative 4x plus 5y is just 1x. A negative 2 and a negative 2 is a negative 4. So this is the first part of my solution. Now remember, on step 3, we said go back to the original. So do not use this equation that we just changed. You need to go back over here to the original. Do you want to use the first one or the second one? Let's use the second one this time, just so it doesn't feel left out. 5 times negative 4 plus 3y equals negative 2. I get a negative 20 equals 3y minus 2. Add 20. 3y equals 18. Y equals 6. So my solution here is negative 4, positive 6. Yes? How are we feeling about this so far? Very nice. All right. All right, so this example looks almost in line, but notice this one is in standard form and this one is not. So you can do a couple things. You can move this 8x over to the right-hand side, or you can move this 3x over to the left-hand side. Move the 3x. So I'm going to rewrite it over here. I have 8x minus 4y equals negative 4. How do we move this 3x over here? We're going to subtract it. So we have negative 3x plus 4y equals 14. Now everything's nice and pretty lined up. Now on this standard form, this one is negative. That's okay because we want this to eliminate. All right, we're not going to worry so much about that particular rule because our goal is simply to solve. So we have 5x equals 10, x equals 2. And again, you don't want to use this equation that we changed. You can go back to one of these originals. Which one do you want to use, first or second? The first this time. Give everybody a chance to be used, I guess. Make sure again that you're putting that in place of the x and not the y. We're going to subtract the 16. We get a negative 20. Be careful with your signs. Make sure you put that negative there. Negative divided by a negative is a positive. So my solution here is 2, 5. And keep in mind that on all of these, you can go to your calculator, plug them in to make sure they work. So I could say 8 times 2 minus 4 times 5 equals negative 4. It works. 4 times 5 is equal to 3 times 2 plus 14. It works. Okay, so don't forget that you can check your work that way. All right, some of you in here are like, there's got to be more. I need you to, we're going to skip to this third page because, but wait, there is more. Now, this first example, not much going on. The first and the second examples, not too bad. I do want you to look at this third example and notice that you really want something to eliminate. You have 2 possibilities that could eliminate. What could eliminate here if we did something to it? What do you think we could do? This 2x, if one of them was what? Negative. So that's going to be a situation like we talked about before. You can multiply one of them by a negative 1, and you could go through and you could solve that. Okay? The same thing, I'm not going to solve this one real quick because I have something else to show you. Same thing on number 4. Look, you have this negative 1 half y, negative 1 half y. If you multiplied one of these by a negative, then you could eliminate them. Okay, and I'll go back and give you these answers so you can do your work and check yourself. Number 5. Okay, here's where the more part is. Number 5. What are you thinking here? Something has to eliminate We're going to have to manipulate something to make it happen. What do you think? Multiply what by 2? The bottom. Not just the y. You have to distribute that on the entire equation. Okay, so just like before we manipulated and we multiplied by a -1, it doesn't have to be a 1. It can, in fact, be a value. So will these eliminate now? Yes. Okay, I'm going to let you go back and do that in a minute. Look at number 6. That's not a very friendly equation. What are you thinking, Luke? Okay, you could technically divide all the way through, but there's not a nice number to divide by. If you divide it by 10, you're going to get some decimals, and those are ugly. Oh, you were looking at 7. Again, this one's not going to be super nice. If this was a 20, then yes, I would divide by 10 and make them easier. Other thoughts here? What are you thinking? We're not going to be dividing. I'm going to give you a hint. We're going to be multiplying. Multiply what by 3? What is that going to do? That's going to give me 18 and 39 and -27. None of those are going to eliminate. Multiply them by each other. Let's do this. Pick a variable, x or y. X, okay. How do we get these to eliminate? Well, we need to find a number that both of them will go into. No, that they will go into. Not. So we're looking for a common multiple, and one of them needs to be negative. So what is the least? 18. Okay. How do I make 9 to be 18? Times it by 2. How do I make 6 be 18? Times it by 3, but they're still positive. One of them needs to be what? Negative. Which one do you want to be negative? It doesn't actually matter. So when we do that, we get 18x plus 4y equals 78. And we get a negative 18x minus 39y equals a positive 27. Could we do it now? Okay, so here's what I want you to take from this. You can multiply by a -1 to make things eliminate. You could multiply by a value like we did on number 5. We multiplied by 2. Or sometimes you need to multiply both equations by a value to get things to eliminate. All right, so I am going to ask you to work through these problems. We are only doing notes today. I am on Google Classroom going to post the answers so that you can check your work. And tomorrow we will do an assignment on this. If you have questions, you need to let me know.